Hello, hello, hello everyone. Good evening. A warm welcome to all of you, particularly those who are coming from outside NYUAD for this public talk. My name is Dattaraj, and I am a researcher at Center for Space Science. And it is my pleasure to introduce tonight's speaker and my colleague, Dr. Dimitra Atri. Dimitra is a research scientist at NYUAD and leads the Mars Research Group at the Center for Space Science here at NYUAD. He is the principal investigator of the Aspire Award for Research Excellence Grant to study the atmosphere of Mars with the UAE's HOPE mission. His group is using data from the Emirates Mars Mission HOPE, as well as NASA's missions such as MAVEN and rovers such as Curiosity and Perseverance to investigate how Mars lost most of its atmosphere and the possibility of finding extinct or extant life on the red planet. He's also interested in human space exploration and is investigating how the radiation in the outer space impacts astronauts in long-term space missions, especially for the future crewed mission to Mars, that is Mars 2117. He is developing strategies on how to sustainably explore Moon and Mars in the coming decades. Before working at NYU Abu Dhabi, he was a research scientist at the Blue Marble Space Institute in Seattle and a visiting scientist at the Tata Institute of Fundamental Research in Mumbai. He earned his PhD in physics from the University of Kansas. Without further ado, I now pass on the mic to Dimitra to deliver today's talk, that is Decoding Mars with the with the HOPE probe. Dimitra.
All right, thanks so much, Dattraj, for the introduction. I hope you're able to hear me clearly. All right, so tonight we are going to decode Mars with the HOPE probe. So UAE has the Emirates Mars Mission, also called the HOPE mission. So let's start with Mars. It's a neighboring planet, so we all like to know about our neighbors. And because it is much further away from us, it takes longer to take one revolution around the planet. So Mars here is about twice as long as Earth here. It's much longer. Mars is much smaller than the Earth, so as you can see here, the size is about half, and the mass is 1/10, so it's very light. Its atmosphere is extremely thin, so it's about 1% that of the Earth. So extremely thin atmosphere made mostly of carbon dioxide. And then you have trace gases such as you have some nitrogen, argon, and so on. And as you can imagine, because the atmosphere is extremely thin, it must be extremely cold, and it is. So most of the temperatures you see are much, much below the freezing point of water. In summer months, in some areas, you have temperature above zero, but most of the time it is extremely cold. So extremely cold planet. All right. But the gravity is about 60% that of the Earth. So in future, if you'd like to go to Mars and if you like to jump, you'll be able to jump much further. All right. So Mars exploration started as soon as people started building rockets. So the first attempt was in 1960, was this Mars 1M mission. It was by USSR. At that time, because of Cold War, there was an intense competition between the US and USSR. And so this mission, it failed to orbit even the Earth. And this has been the story of Mars exploration. You have mostly failed missions. The first success was much later in 1965 with this Mariner 4 probe. It did a flyby of Mars, which means that it went just past Mars. It didn't go into orbit or land, just going close through Mars. And then this is the most interesting image. So the mission was successful, the data was coming, and everyone was eager, okay, but there were no computers like this today. So all the data which came in form of ones and zeros, they put colors, and this was made by hand. So the first image from Mars that we have from a space probe looks something like this. And then obviously people made a lot of fun because it was such a huge deal at that time. But then they processed the image, so it looked something like this, which showed that Mars has craters on the surface. So which means it has a thin atmosphere. So this was in 65. Then 1971 was a huge year for Mars exploration. There were 5 launches, very intense competition, and you can see that within a period of few days in the month of May, you had both the US and Soviet missions going to Mars. So the thing was, okay, who is going to make it first? And Mariner 9, which is NASA's orbiter, it reached orbit on November 14th, 1971. And still, if you go to NASA JPL's website, it says that, we beat the Soviets still. Then just 1 week later, there was the Soviet mission called Mars 2. It entered orbit, so just 1 week later. And it also had a lander. So this Mars 3 lander, it landed on Mars on December 2nd, 1971. This was the first ever landing on Mars. Now, although the mission failed after that, it failed to communicate, but we know that it was safe. It also had this small rover which could move around. We don't know what happened to it, but this was extremely significant that we were able to land something on Mars. And December 2nd, 1971 is important because people here know, because this was also the founding day of the UAE. So Sheikh Zayed traveled from Abu Dhabi to Dubai. He signed the agreement. The Emirates was born. He became the president. So the link between UAE and Mars goes back to the 70s. Then in 1976, this was a groundbreaking mission. So NASA's Viking 1 and 2, so these were 2 orbiters and 2 landers. So 2 missions, they went to Mars a few days apart. They both orbited, and then they had 2 landers on different parts of Mars. And the reason was, at that time, there was excitement about finding the possibility of life on Mars. And Carl Sagan was leading this effort. He was a big believer in astrobiology. He really thought that maybe we'll find some biological activity on Mars. So that's why there were 2 missions. NASA had funding. And so the idea was, if one of these landers found some evidence of life, how do you know it's not a fluke or something? So then you had another one doing the same set of experiments, and if both of them had life detection, it meant that it had life. But unfortunately, it didn't find anything, and I'll tell you later why. And so this highly successful mission became a bad thing for Mars. 1976 was also the foundation of UAE's space program. So here Sheikh Zayed is meeting with Apollo astronauts. He was discussing the possibility of having, space research here in the UAE, and here we are. So overall, if you look at the 20th century, you had intense competition, right? In the 70s, the Viking mission could not find any sign of life, so people lost interest. So you see there is a huge gap. There are no missions there. Then there were some missions by NASA which were highly successful. And then after that, there were a bunch of failures. So 3 missions, and these are, billion-dollar projects. So 3 failed side by side. So it was a huge setback. Now, coming to the 21st century. So in the 20th century, only the US and USSR attempted Mars. In the 21st century, European Space Agency sent an orbiter, Mars Express, around Mars. And it entered on Christmas Day in 2003. It also had a lander called Beagle 2. So Charles Darwin did his work on the Beagle, voyage of the Beagle. So this was named Beagle 2 to find signs of life, but the lander unfortunately failed. And most missions to Mars, 50% fail, so it wasn't a surprise. And this orbiter is still functioning. It is still giving us data. So, this is amazing feat of engineering. And then in 2014, India's ISRO sent an orbiter around Mars, Mangalyaan, and it just shut down just a couple of months ago. So it sent data for several years. So it's an exclusive club, as you know. 20th century, 2 countries, 21st century, European Space Agency and ISRO. And then in 2020, you had 3 missions. So launch schedule was, UAE's Hope probe, then US Perseverance rover, and China's Tianwen-1 mission. The interesting thing is, the 3 countries where these missions were taking place, NYU has campus. So, in Abu Dhabi, New York, and Shanghai. And the interesting thing is 2 out of these 3 missions, they are from Asia. So this also shows you how the world is changing with time. So here in the UAE, as you know, many of you would have followed this. It was very exciting. So the spacecraft was assembled in the US, then it was brought here in the UAE for final testing. And if you were, on Dubai highway around that time, you would have seen, this is the Hope probe. This is being transported by this truck and then put on this aircraft. From Dubai, it went to Japan. So Japan launched the mission. By the way, Japan itself never went to Mars, but they launched this Hope probe. All right, so on July 20th, 2020, it was the launch of the Hope probe. Spectacular, flawless launch. We were all in lockdown, so we were watching from home. It took several months, and on February 9th, it reached the Martian orbit. And here is Her Excellency Sarah Al-Amiri. And she was the science lead of the mission at that time, so she was very closely working with this. And so it was, during lockdown, everyone was scared. So this was an outdoor event in Dubai. And you can see I am sitting right here, and everyone was nervous, what is going to happen. And then finally, she announced that, okay, we have reached Mars. So it was amazing. One of the most exciting moments. All right. And then the whole Emirates Mars mission team was honored by the leadership of the UAE. And just the next day, this first image was released. It shows, the volcanic region, the Tharsis region of Mars. All right. So what does HOPE do? So HOPE probe, it's a satellite. It's an orbiter around Mars. It has 3 instruments. So EMIR's instrument is an infrared spectrometer. It sees in infrared light, and just like a prism breaks light, this instrument breaks infrared light, and you can see fingerprints of many things. For example, you can measure the temperature of the surface of the atmosphere. You can measure dust, different types of gases, ice, and so on. So that is what Emirates instrument is used for. EMUS is the UV spectrometer. So it sees things in ultraviolet, so higher energy processes. For example, auroras on Mars, which I'll show you. And then this is the EXI instrument, which is taking photos in the visual band. So the photo which you saw earlier, this was taken by the EXI instrument. All right. Now, what makes HOPE unique? There have been so many orbiters around Mars, so you might ask, okay, there is another orbiter. What is so special about this? Now, if you see, so this is Mars, and these are, current orbiters. So MAVEN, NASA's Mars Global Surveyor, Mars Reconnaissance Orbiter, Mars Express, the European one. They are very, very close to Mars. So when you're close to Mars, you can take really good high-resolution images, but then you're also seeing a small area at a time. You don't know what's going, somewhere else. For example, just on Google Earth or Google Maps, if you, zoom in to NYU campus, you cannot see, anything else, what is happening in rest of Abu Dhabi or Dubai, right? So other missions, they have different objectives. So they try and go as close to Mars as possible. HOPE, on the other hand, Al-Amal is the name in Arabic. It is much, much further away. So from it varies between 20,000 to 40,000 kilometers. And the advantage is you can see the whole planet at once, which no mission has done so far. So it is, like a CCTV camera. It is watching everything. And so for the first time, we have this global coverage. Other missions can find, something interesting, and most likely it has been captured by HOPE. So now you can study things by using two different missions. And that's what we are doing. All right, so I already told you a number of things which can be measured. So in the lower atmosphere, you can see ice, CO2, clouds, you can see ozone. Mars has some water, you can see water vapor. Mars has a water cycle. You can measure atmospheric temperature. Dust is a huge thing on Mars because it is very similar to the UAE. So you know about dust. Then much higher in the atmosphere, there are other species such as carbon monoxide or oxygen. We can measure that. And then much higher up in the atmosphere, you have hydrogen and oxygen. So what happens when water vapor, when it rises, because Mars has a thin atmosphere, radiation, there is enhanced exposure to radiation. So UV radiation, it breaks water H2O into H2 and O2, and then it goes up further, H and O. So around Mars, you can see a lot of H and O, and I'll come back why that is important. So these are some of the images. So as soon as the data from the mission was released, we were all eagerly waiting for it. So we were hooked to these. So this spectacular image is called Valles Marineris. So this is like Grand Canyon, on Mars. So this is 4,000 kilometers long, 200 kilometers wide, and 7 kilometers deep. And such a beautiful image from the HOPE probe. This is another image. It shows the Tharsis region, which is a volcanic region. In that you have this huge volcano called Olympus Mons. Its height is 21 kilometers. So Mount Everest is 8.8 kilometers. This is 21. And you can also see 3 other volcanoes. Don't worry, they're all dormant, so you're safe. And And just to the side of it, there is a very complex butterfly structure, which you can see here. So this is Olympus Mons, the biggest volcano there, the butterfly structure here with a very interesting formation process. And just to give you an idea of the size, this is the size of the UAE. Okay. All right. So what we did was we combined all these images that we got from the HOPE probe. We mapped the entire planet and we made an atlas out of it. So the Atlas of Mars, the photographic Atlas of Mars. Now other missions, as you know, NASA has been going and taking photographs since the 70s. So other atlases have photographs in them in bits and pieces. But when you look at whole of Mars, those are mostly computer renderings based on data. So this is the first atlas which is entirely photographic. Then we also launched this atlas in Arabic. And so this is the first ever Mars atlas in Arabic. And this is great for Arabic speakers here in the UAE and across the world. And the students, Ahmed, Katrina, and Shamshid worked on this. Katrina is there. If you have any questions about the atlas, you can talk to her. We also have this website, marsatlas.org, where you can go and browse through these images and download the atlas. We are working on a second version, which will be, we'll go to a professional publisher for that one. All right, so then we also made a 3D interactive interface. So we also have a 2D interface like Google Maps. This one was made by Abdullah. Abdullah is right here. He has traveled long distance to come to this talk. And this is just a quick demo. So this is from several months ago. Now we have a much improved map. But just to give you an idea of what it looks like, you can explore different parts of Mars. You can click, you can learn about different features, and so on. All right. And this is the Mars exploration family portrait. You can see so many missions starting, all the way to UAE's HOPE probe now, China's Tianwen-1, and NASA's Perseverance. So many missions to Mars, right? So now why do all these space agencies spend billions of dollars on these missions? Why Mars? And so the reason is we have ample evidence now that Mars once upon a time had liquid water on the surface. It had a thick atmosphere. It had stable liquid water on the surface. On the left, you can see this is an artist's rendition of how Mars would have looked like. And this was, around 3.5 billion years ago. And this is what Mars looks like now. It had, large lakes, seas, and it could have had this ocean in the north. If you look at the data, so this is from one of the NASA's orbiters. It has an instrument to measure altitude of different regions of Mars. So blue is deeper, red is higher. And as you can see, the northern part of Mars is on an average a few kilometers lower. And the idea is that that place was probably an ocean about 3.5 billion years ago. Another evidence is hydrated minerals. So we have minerals on Earth which are made in very specific physical and chemical conditions. You find the same minerals on Mars. If you find a mineral on Mars, you know exactly how it was formed. So there is this mission called Mars Reconnaissance Orbiter. It has an instrument called CRISM. It has, this is just one sample of from orbit. It has detected these minerals. And these are all hydrated minerals which form in the presence of water. So you know that, water was there. Then now we have a new era of Mars exploration. We are not, just orbiting or landing. We have now things, robots, which can move. So this was the oldest one, and these humans are just for scale. So this was, the Sojourner. It was just to test whether rovers can work on Mars or not. And so it went around, did a lot of experiments, and it was highly successful. So NASA then decided to launch 2 of these. So these were much bigger, Spirit and Opportunity. And the nominal duration of the mission was for 90 days. So they were supposed to survive for 90 days. But one of them lasted for like 15 years or something. Just very recently it died. And then as technology grew, you can see, this is the size of a big SUV. And it has so many instruments on board. Big tires, it can move around, it can do things. This is the Curiosity rover, and it has been working since about a decade. And NASA has a new rover which launched with Hope, which is called Perseverance, which looks very similar to this. So this is a new era where you can actually go to Mars and you can touch and feel things. So that's what we do. We use Hope to see things, and we touch and feel using this. All right. Now, UAE looks very much like Mars because they have similar, processes through which different places form. So this is a comparison of, Mars and UAE desert. So we go out in the desert and we look for features which look like Mars. And we find so many features here. So Vignesh here, he is our one and only geologist. So he knows what he's doing. And so these rovers, when they go there, they can take photos of Mars, different rocks. They can drill in them, they can take samples, they can analyze them. They also have lasers through which they can assess the chemical composition. So we know a lot about these rocks on Mars. And we find similar features here, and then we compare them. And then we try to create the history of Mars using what we found here, mostly in Abu Dhabi. So here you can see conglomerates. So these are, as you can see, you find these features, when there is liquid water, right? Then you have these alluvial fans that you see from orbit. There were rivers. So in the UAE, you have ancient rivers, also found on Mars. If you have gone out and seen Sabkhas, you see these polygonal structures. You also see them on Mars. You see these ripple marks on Mars, which you can also see here. So we measure things, and then we compare to Mars, and we try and understand what happened. There are many places, so I can just go on and on with photos, which look like Mars, but I have just taken one. You must have seen, Al Watba fossil dunes. This one is taken by Curiosity rover, with similar formation process. One of the features you see, the red one is Mars, the blue one is here in the UAE. So I can just go on and on with these features. You just go out and you can see Mars here in the UAE, and we go out and study them. One of the most interesting ones is this flower structure. So this was several months ago. We just got the data, we opened it, and I thought, it was a joke, but no, it was real data, this flower-like structure. And we find similar things here in the desert. And so we have a study coming out where we explain how these are formed. So just 2 years ago, when Hope reached orbit, just a few days later, NASA's Perseverance rover it landed. The place was a crater called Jezero crater. So the reason why you go in a crater is that if you look at the walls, the whole stratigraphy is exposed. So you can see how Mars changed as a function of time, just like you do on Earth. And so Jezero crater looks something like this. And as you can see, this is probably a delta. So there was a river, it carried sediments with it, and it deposited. It looks so clear in this. And this rover has been exploring this area there in person, collecting data. And it came up with this animation. This is how Jezero crater, where this rover is, it looked like. This is how it looks like now. So now overwhelming evidence that there was water. All right. So on Earth, if you look at geological timelines, so here on Earth, you can see, oldest life forms between 3.5 to 4 billion years ago. Both planets, so if someone was looking at the solar system from the outside, you would see two planets, Earth and Mars, both had water, right? And we know that on Earth, how life originated, how it evolved, and so on. What happened on Mars, we don't know, okay? But the good thing is, on Earth, there are a lot of activities which erode the surface, right? So it is extremely difficult to find old sediments or old rocks and things like that. So these dots show that there is hardly any evidence of things 4 billion years ago on Earth. Around 3 million years ago, you still have something, right? But on Mars, because there is very little erosional activity, you can see that surface, 4 billion year old surface exposed. You can clearly see it on Mars. So it also contains the history of the solar system, what was happening 4 billion years ago. And you can then, see maybe it also impacted Earth. So you had a planet with ample amount of water on it. What happened? Did life emerge there? Did it survive? Maybe if it went extinct, can we find signs of extinct life? Maybe it survives still now. There are microbes which can live here in Earth in extreme conditions. Maybe on Mars they do. So can we find these microbes? So just to give you a bigger context, why is this important? Why are we looking for life? So this is our story, right? So this whole thing, universe, started with a big bang, and there was nothing, and then something happened after this. Then after some time, you had the formation of stars, galaxies, planets, and so on. On our planet, you see this history. In the beginning, there was no life, and then life emerged somehow. So in the whole universe, you see these are all, dead things. When we see outside, we don't see any life. So how does this happen that, from stars, from this dirt, you have something living? So from non-living to living, this transition, nobody knows how this happens. And so this is one of the most important challenges of our modern times. Because we understand these things really well. We understand how the universe has evolved. We can measure it very precisely. We can measure particles. So we know how the atom is formed. We know how things such as protons and neutrons, they are also formed by even more fundamental particles. So we know that. And so the main challenge, which I like to show is, from this basic elementary particles, how do you form life? And, this is the biggest challenge. And this is, my goddaughter, June. She is much bigger now. All right. So from hope, we are trying to answer these two fundamental questions. Did Mars ever host life? Or how did Mars lose most of its atmosphere and water? So Mars had atmosphere, it had water, and now it is completely dry. So what happened? How it happened? Okay, so we use this data from the Emirates instrument. We can measure things such as surface temperature. So this work is done by Noor, who is here. So if you have any questions, she's here. This is the whole of Mars. You can see during noon time and evening time, this is the temperature. So at noon, it becomes hot. In the evening, it becomes colder. Now the thing is, this data point is taken right here. So Mars in its orbit, the distance between Sun and Mars changes. So when it is closer, it becomes hotter. When it is further away, it becomes colder. So as you can see, it is right here. And this spot, this red spot that you see, it is shifted towards the south because of the tilt of the axis. And as you can see here, it is also tilted towards the south. Now, other missions have also measured surface temperature, but because they are so close to Mars, they'll go and measure temperature, in one point, or the point over here. This is the first time we are able to measure the temperature of most of the planet at once. So this is very useful data. So Mars, this HOPE probe has been orbiting Mars for now 2 years, 2 Earth years. So 1 full Mars year. So we have this data of 1 full orbit around the Sun. And this has been done for the very first time. We have very detailed maps. Then we can also other things such as dust, water vapor, clouds, and so on. So here on the top you see ice. So more white means more ice. So as you can see, when Mars is further away from the Sun, you see more ice here. When it is closer, you see less ice or almost no ice. So we can now study these things on a diurnal basis, so day-night, 24-hour cycle. How does ice, how does water vapor, how does dust, clouds, and so on, how do they change as a function of time on a daily basis, but also on a seasonal basis, because now we have 1 full year data, and the mission is still going on, and so hopefully we'll have many, many Mars years of data. We also use data from rovers, because when you see something with HOPE, because it has a full coverage, maybe the rover is also seeing the same thing. So this is taken by Curiosity rover, so it is looking at the Martian sky. See this, how clouds move on Mars. This is so amazing. Like, who could have thought that we have something on another planet which is looking at the sky. And even more amazing is picture of the Earth taken from Mars. So now if you go out, you can see these planets in the sky, right? You go out in the evening, probably not tonight, but any other night. You'd be able to see Mars. You can see Earth in the Martian sky. So we have done a comprehensive study of how this surface temperature changes and so on. And this was the first study, so we published this. And so here you can see, this is the full map of Mars and how the temperature changes during the day. So from night time, so this is 2 to 5 a.m., 5 to 8 a.m. Then you go to the afternoon, and then later during the day till midnight, how the temperature changes throughout. And based on all this data, so we have not just surface temperature, we have atmospheric temperature, dust, water vapor, and all these things. Now it is possible to make a data-driven model of Martian weather and climate. And so Noor is leading that effort. along with Dattraj and Mathilde. So Mathilde was an undergraduate student. She was a computer science junior working on this at that time. She's a senior now. And now she has an offer from Cambridge University for master's program. When we compare this with rovers, so the two NASA's rovers, they have instruments to measure temperature. So when we compare, so these are the locations. So when we compare the temperature, we find a systematic difference between what you measure from orbit and what those rovers are measuring. And now we have understood why. And based on that, now we can refine our estimates of surface temperature of Mars. So Mars is most likely a bit warmer than we previously thought based on these results. And we have a number of studies based on this coming out. So moving on to space weather. So our sun is highly active. It doesn't look that way because Earth has a very thick atmosphere. Earth has a magnetic field, so we don't care about the sun on a day-to-day basis. But sun is highly active, and sun emits hot plasma or hot charged particles continuously, and those continuously interact with all the planets. So on Earth, as I told you, we don't have much impact of it, so we don't care. But Mars, it lost its magnetic field really quickly. So I showed you earlier, right? Mars is 1/10 the mass of the Earth. So it cooled down very quickly. Its magnetic field went away. So when there is no magnetic field, all these charged particles started bombarding, right? And so what happens when these charged particles bombard Mars? So this is just to show you. So, okay, this will give you an understanding what happens to a planet. So this is how we think Mars lost most of its atmosphere. It lost the magnetic field. Solar wind drove erosion of the atmosphere, and we are trying to understand it in more detail. So this is just an animation. It was based on measurements by NASA's MAVEN mission, which we also use. This is going to show you how exactly it looks like. So when you see, a boat going, in water, it forms these waves, right? It is called a bow shock. That's the shock that you see here. And then all these particles, they are, ejecting from Mars, which we can see now. So this same process is going on till now. So if we go to Mars, we observe this, we can then extrapolate back in time, and then we can, figure out how Mars was and so on. And so this mission can measure charged particles. Okay? Plus it is very, very close to Mars, so it can take only a small sample at a time. So HOPE comes into play. HOPE can see the whole disk at once. It can measure neutral particles. So now you saw, charged particles interacting with Mars. On Earth, when you go to polar regions, you see auroras, right? You can see these bright lights. Because in polar regions, you have very strong magnetic field. So charged particles, accumulate there. And interaction between charged particles and atmosphere leads to these emissions called auroras. So you can also see auroras on Mars. Other missions have seen it. You see something like this. So these are taken by the EMUS instrument, the UV spectrometer. And if you see this one, these are auroras. So you can see, scattered around. So Mars does not have a global magnetic field. It has magnetic field, scattered around. Very weak magnetic field in bits and pieces. So you would expect something like this. and Hope saw it. Okay, it is fine. But then for the first time, you see these auroras. So the diameter of Mars is 7,000 something kilometers. 3,500 kilometer long aurora. You see this? So these have been observed for the very first time with Hope. Now think about this. Mars exploration has been going on for 50 years. First time we are seeing this because of the unique orbit, plus the instrument is highly sensitive. And so now this is a challenge. You should see auroras in bits and pieces, but you should not see these auroras. So we don't understand this physics. So now we are trying to figure it out. And so Dattaraj, who introduced me, is leading this effort. And the reason why we are studying these in great detail is because solar wind, it interacts with the Martian atmosphere and magnetic field in very, very complex ways. So I am not going to explain this because it would take me, one full hour just to explain this figure. But this escape process is extremely complex. How, solar wind interacts with the magnetic field of Mars, with the atmosphere of Mars, is very, very complex. So what we do is we study these auroras. So some auroras are caused by electrons. Electron auroras, they have a certain type of physics. Some auroras are caused by protons, by the sun. These are called proton auroras. And both of them generate different types of emissions. So by studying them, we are going to create this picture of how does solar wind interact with the atmosphere of Mars, and ultimately how it lost its water. So as I mentioned to you earlier, right, you have on Mars, you have water vapor, it rises, then it becomes hydrogen and oxygen in the atmosphere. Because of solar wind, this hydrogen and oxygen goes away. So you can see this on Mars today. Hydrogen and oxygen is escaping. You can measure the rate of escape, and that then you can trace it back in time to figure out how much water could have existed, how much atmosphere could have existed, and so on. All right, so now we know about the processes in the atmosphere. Let us look at, search for life on Mars. So as I mentioned, Viking mission was so important in 1970s, looking for signs of life. It didn't find anything. And so, for a very long time, there were no missions. Now, the reason it could not find anything was the instruments were not sensitive enough. There are organic substances on Mars, which I'll talk about later. But, it was 1970s technology. They didn't find anything. In 2018, there was a lander called Phoenix. It discovered these chemicals called perchlorates on Mars. So these are salts which are used as explosives. So when you see, fireworks next time, these are made of perchlorates. So these perchlorates, when they interact with UV from the sun, they would destroy all life. So this paper in 2019, it said that, okay, Mars is highly toxic and no life could exist. There was a work done in the 90s on a meteorite. There was, some features which at that time they announced maybe it could be life. They can be, formed by regular chemical processes. So it became highly controversial. So anything to do with life, it eventually becomes highly controversial. So this Curiosity rover, it landed about 10 years ago. It landed in Gale crater. This is another crater which was full of water. There is plenty of evidence. And it found a number of organic compounds, benzene rings, full benzene rings on Mars. So now the question is, Mars has such a harsh environment. It has UV, it has, very low temperature, it has these toxic perchlorates. How are these organic substances surviving there? and maybe something else survives. So here in the lab, so in NYUAD, we have a collaboration with the Smart Materials Lab with Professor Panche, who is right here. Other people working on this, so Maria, Vignesh, and Zainab. So what we are trying to do is we are trying to create Martian conditions in the lab here. And we are trying to study how do organics behave. So no sample has been returned from Mars. So we have a replica of Martian soil. And then we expose it to UV. We put in different organic substances there. And we see how they behave. So our ultimate goal is to figure out how does organic chemistry operate on the surface of Mars, and then can something like biology exist, or can it support biological activity? Another important thing is mechanochemistry, which is also Panche is an expert on this. So Mars, as I told you, it has these dust devils, a lot of dust activity. This is InSight lander on the surface of Mars. It landed in 2018. And you can see before and after. So now it is completely covered by dust. And the mission had to shut down, right? Because solar panels are covered with dust. There is no energy to power it. So it's gone. And so this chemistry of dust, Mars also has impacts. So maybe in solid state, all these things can have some impact on chemistry. So this is also something that we are investigating in the lab. We are also looking for biosignatures from orbit. So biosignatures are gases which are generated by biology on Earth. And if we find such gases on Mars, maybe they are generated by biology, we don't know. And so we are looking for these biosignature gases. Methane is one of those gases. So there are several missions who have looked for it, but the results are inconclusive. And this is a highly controversial subject. So our two students, Gopika and Jeonjin, they have been, especially Gopika, for last several months, we have been investigating this. And soon we'll be able to answer this question from Hope, because we have the full coverage. So stay tuned. Now there are future missions. So the surface of Mars, it's a very harsh place. So it is not surprising that, we didn't find any life. But so far, nothing has been explored below the surface. We are, literally scratching the surface of Mars. So this mission, European Space Agency's ExoMars, it is planning to go to Mars and dig 2 meters deep and take these samples. So 2 meters deep, it is not exposed to this harsh radiation. It is not subjected to such cold temperatures. Maybe there are pockets of water. So when there is high salt, Mars has high salt, water can stay in liquid form even at very, very low temperatures. So there are likely, liquid water below the surface, just 1 or 2 meters. So this is going to go in a few years. We don't know exactly when. And then NASA is going to send a similar mission with a drill capable of drilling 2 meters deep to look for signs of life. So I'm looking forward to these two. Then the first sample is going to be returned in 2033, 10 years from now. So it is a joint mission between NASA and the European Space Agency. They're going to go there. So this Perseverance rover is already collecting samples and packing them in tubes. So this mission will go there. It will collect them. It will bring them back to Earth. And maybe, some of the samples will come here. Who knows? Recently, China also announced that they are also going to attempt a sample return mission with a delivery date 2 years earlier. So this is going to be very interesting. All right. So now, we are talking about these robotic missions. Let us say, with this, you find some signs of life. But the thing is, you can only pack, limited amount of instrumentation in these labs. So even if, there is microbial life, maybe these instruments are not sensitive enough to detect that kind of life. And so even if these missions are highly successful, the result is going to be highly controversial, right? Where is the proof? So the ultimate solution is for humans to go there. So we already went to the moon, we explored it. And so maybe in the 2030s, 2040s, there'll be missions where people will go to Mars, and one of their main objectives will be to explore, signs of life. UAE has this strategy called Mars 2117. So this is, UAE's official strategy, where the goal is to have a city on Mars by the year 2117. And so HOPE mission is just, first step in that direction. And hopefully there will be more missions to Mars to gather more data and then eventually prepare for this. So talking about astronauts, we also have a group where we study how a human body behaves in space. So so CERN uses a software. CERN is this Large Hadron Collider where Higgs boson was discovered in Switzerland. So they use a software where they model how these particles, how high energy protons interact. So we have modified it to work with the human body. So as I told you, you have charged particles coming from the sun. When you're out in space, there are charged particles, very energetic, which are everywhere in the galaxy. You're exposed to that. So those interact with the human body. So now we are able to calculate the damage in each organ of the human body. And then we compare it with medical literature. So when you go and for treatment for cancer, there is radiation therapy now. So in addition to destroying that cancer, it also destroys a part of the human tissue which has been studied. So we then compare how much damage would occur. We also use this data. So one of the rovers, it has instrument to measure radiation. We use it. We then make a radiation map of entire Mars for future missions, which would be the most likely places where humans should go. So, this is an ongoing adventure. We have learned a lot, but we have a lot of unanswered questions. Mars, now we definitely know that, it had abundant water. It turned into this. Now we have fairly good understanding how this happened. So the question is, will the same thing happen to Earth? Okay, we don't know. So I would like to thank, a lot of agencies. So NYUAD Institute, Research Institute for funding this. External agencies, Aspire, ATRC, RPI, Srini, and all the students and researchers who work with us. Unfortunately, I could not, put everyone. I don't have photos of everyone, so this is a small sample. I would like to thank the teams of these missions. So HOPE missions, NASA's MAVEN, Curiosity and Perseverance. Without them, we would not be able to do anything. So before I end, I would like to share something. So when the mission sent its first photograph, the image was so spectacular, and one after another, we started seeing images. So I thought, well, maybe we can create a global map, first ever global, using photographs. And these were one of the first attempts, the photos, the angle between the sun, the spacecraft, Mars. So things, don't patch up properly. There are dust seasons on Mars, there is ice, water vapor, they all throw off, colors and so on. So combining these images is extremely difficult task. And Abdullah here has been working for several months on this. So finally, I can show you. So it has taken a very, very long time, one full Mars year of data. And this is the first photographic global map of Mars ever. And outside our little group, you are the first humans to see this. So this is how it looks like. And with that, I'd like to thank you. Thanks so much for your time.